the first part of this next unit deals with transforming parent functions. Right here is the general format for those transformations. One of the things that you need to have an understanding of in this format is that this part right here represents the parent function. So f of x equals the parent function. F is not going to be a number that you are going to multiply by. It is simply a representation. Okay. So the components, though, that we are going to look at would be the a value, the c value, and the d value. Okay. Starting with the a value. The a value, the first thing that it tells us is whether this graph, or whether this function, parent function, has been vertically stretched or compressed. Now, when we're thinking about stretches or compressions, I want you to think about if you had a piece of gum that you took out of your mouth, and if you pulled that vertically, it is stretching and getting longer and more narrow. Okay, that occurs when the a value is greater than 1. Okay, so if a is greater than 1, then my graph has a vertical stretch. Vertical stretch. Numbers greater than 1 could be 2, 1.5. Anything greater than 1 is going to cause that function to have a vertical stretch. For example, let's see, y equals 2x squared. That is a vertical stretch by a factor of 2. What that means is that my graph is 2 times taller than it used to be. If a is between 0 and 1, we're only discussing positive numbers right now, okay? If a is between 0 and 1, then we have a vertical compression. Once again, think about that piece of gum, and if you press it back down together, then it becomes flatter and wider, shorter and wider. Okay, so that's a compression. An example of that could be 1/2 or 0.7. Those would result in a vertical compression. An example of that with a function, let's do the square root function. Let's say that I've got y equal to 2/3 square root of x. Okay, that is a vertical compression. I'm abbreviating here. It's a vertical compression by a factor of 2/3. In other words, it's 2/3 the height that it used to be. Okay, that a value causes another change. Okay, if that a value is negative, it's going to cause a vertical reflection. Okay, so if a is negative, then we have a vertical reflection. Vertical being up and down, right? Vertical reflection. An example. I'm going to show you an example with a graph. Let's just use the square root function again, because that one's easy to flip. So if I have y equal negative x squared, well, you know the parent function of x squared looks like this. Okay, but if it's negative x squared, then that causes it to reflect vertically. It flips upside down. Okay, so that's the a value. Next, we deal with the c value. Notice that we skipped c. It's not a mistake. We skipped b. We skipped b. It's not a mistake. We'll deal with b after Christmas when we look at trigonomic functions. But the c value causes a horizontal shift. Now, what you have to be careful of is that c value is going to shift the opposite of what it seems. And what I mean by that, that if I've got x minus c, then it actually shifts to the right. Which means if I've got x plus c, then it's actually a shift to the left. Anything that happens inside the parentheses is going to be the opposite of what we think would happen. Okay, example, let's use the rational parent function. Let's say I've got y equal 1 over x minus 2. That's actually going to cause my graph to shift 2 to the right. Okay, if I've got y equal, let's do the ln. Let's say I've got y equal ln x plus 4. That is a shift of 4 units to the left. Okay, last one. Last one is probably the easiest one for you guys. You've been doing the last one for a long time. D is the vertical shift. If that number at the end is positive, if you're adding a positive to the end, then it moves up. If it's minus a number at the end, then it moves down. Okay? Example, what's a function we haven't used? Let's see. Let's say I've got y equals, whoops, I'm sorry about that. Let's say I've got y equal x to the third power, the cubic function, plus 7. This graph is going to shift up 7. If I've got y equals x cubed minus 4, then this graph is going to shift down 4. Okay, let's do an example where we put them all together. And we'll just go with the quadratic. Okay, so here we've got y equals negative 2 x plus 6 in parentheses squared minus 5. Okay? This 2, this negative 2, has actually caused 2 transformations. The first thing I know that it's doing is a vertical reflection because it's negative. Okay, so it's got a vertical reflection. And that's because it's negative. And this 2 right here tells me that there is a vertical stretch by a factor of 2. It's going to be twice as tall as the parent. Okay, now then, let's look at this plus 6 that's inside the parentheses. That plus 6 tells me that my graph is going to have a horizontal shift six units to the left. Let's just say shift 6 left. Don't have room. So 6 left. Okay? And then the last part here is minus 5, means that my graph is going to have a vertical shift five down. Okay? Another rule of thumb for you real quick. Anything that is happening inside the parentheses is going to be horizontal. Anything that's happening outside the parentheses is going to be vertical. We'll talk about that some more. And that is transformations of parent functions.